becomes a to the 7.
Negative x.
All right, let's do a problem like that. Because if you guys were taking stuff and moving it that it was illegal to move. So what I mean by that is if I have 4a negative 2 over 6a 7, let's say I have this. There are two main ways to do this. You don't have to do it the way that I described. You could just go ahead, what do you do when you divide? Subtract. So you can subtract, and then, but to me it's so much easier to, if it's to a negative power, what does that mean? Flip it. So what's the only thing up here that wants to move? This guy. Because what's 4 to a power of? 1. Understood 1 up there. 4 is not to a negative power. It has no reason to flip. So the only thing going to flip is this guy. This guy goes down. That 4 is still there. That 6 is still there. Those 7 A's are still there. But those 2 A's came down. And now the next step is really easy. Yeah. 4 over 6A to the 9.
No, why does it want to flip? Why do you?
Because negative powers, when do I lose, how could I make that 8 become a 6? What could I divide by to make the 8 become a 6?
X squared. Oh,
X squared, right? That would make the 8 become a 6. Cool? So far, so good?
Yeah.
No, what's up with that?
I don't know. I missed that whole lecture. I was sick.
Just remind everybody, why do I have to pick 8? That's 4,
No, right.
4, that's 8. How many cancel? 2. How many are left?
6.
6. So since the exponent keeps track of how many things I'm multiplying, if I divide some of them, they're going to go away. So I had 8 x's. If I divide 2 away, I've got 6 left. Right? Please, dear God, don't do this. You shouldn't have to do that. That's the reason. That's the reason why it works. But if I had x to the 8th power up there, you do not want to turn your paper this way and start writing 80 x's. Dear God, please don't do that. Right? That's why it works. But what's the rule now? Subtract when you divide. What else could I do? What could I put here to get x to the 6th at the end? Because I know what do I do when I multiply. What do I do with the powers? Add them. So what do I add to 8 to make it 6? Negative 2. Right?
Yeah.
Which on one level is why they want to flip. Because what does x to the negative 2 have to be then? It has to be 1 over x squared. They do the same thing, don't they? They do the same thing. So negative power is like having a debt of 2 x's. I have not just no x's, but this little dude he's in debt for 2 x's. I don't know if that's the best way to describe this, but if I have 8 x's, that's great. If I divide 2 away, that's like giving somebody 2 x's away from what I got, right? Well, if I got 8 x's and I owe somebody 2, how many are you going to have left at the end? 6. They're the same damn thing. So when I raise something to a negative power, it really does want to divide because it wants to make it go away. It wants to make fewer x's. And how do I make fewer x's? Divide.
So when you're multiplying by a negative, it wants to divide.
When you raise a power, when you raise something to a negative power, it'll make it flip, because that's what it does. And really, the real proof we used when we talked about this was here. If I have x cubed, what would I put on the bottom to make it x to the negative 1? 4, right? Because then 3 minus 4 is negative 1. But then what is x cubed over x to the 4th? How many? Yeah, exactly. How many x's cancel? 3. How many are left? 1. Where? So these are the same thing. They have to be the same thing because they both come from the same beginning. If this equals this and it equals this, these two have to be the same. Right? It's actually called the transitive property, but it's something I call the duh property. If this is the same as him and this is the same as him, these two are the freaking same. Right? If I'm as old as you are and you're as old as he is, he's as old as I am. It's like, well, yeah. Right? So that's a beautiful way to do a proof, is to do something one way, do it another way, and say, oh, I just proved that these two are the same damn thing because they start at the same place. So what does a negative power mean? Flip. Maybe.
Yes.
And the same thing if I had x to the 8th over x to the negative 2. If I apply the division rule first to this, what is 8 minus negative 2?
10.
10. 8 plus 2. So doesn't it act the same as this?
Yes.
So that's these two want to come up. It's a nice shortcut to all my work. Anything to a negative power doesn't like where it is. It wants to be on the other side. So once it gets there, it's happy. That's another way to put it. A less technical way, but an easy way to remember. Right? Okay. So in a problem, when I have a lot of stuff going on, like this problem here, now the numbers, don't leave them out of things. The numbers should be the easy part of this problem. 40 over 32, what can you divide both of those by? Just reduce it, right? 8 goes into both. 8 goes into 40. 5 times. 8 goes into 32. 4 times, all right? So the first piece of this is done. Now who wants to move? Yeah, these 4 x's want to come up. So those 2 x's are still there. And those 4 x's come up here. What else wants to move? Yeah, those 7 y's want to go down. Those 8 y's are still there. They don't want to go anywhere. They like it down there. 7 y's like, shit, this sucks up here. Want to come down here? Yay. So then what do I get? 5, 6, good. Over 4, 15. Cool. Exactly. Now if you wanted to, and I want to make this clear, I like this way because it really reinforces what a negative power means, because that's the hardest thing for students to get down. So if I can make you do it over and over and over again, you might remember what negative power means flip. The other way to do this is, what do you do when you divide like bases? What do you do with powers? What do you do when you divide? You subtract. What's 2 minus negative 4? 2 plus 4 is 6. What's negative 7 minus 8? Negative 15, which would then flip down. I mean, see, that works also. But you open the door to making really easy negative mistakes. I always see people do this. Right? Because they just see an 8, they see negative 2, and that makes 6. So leave me alone. No. 8 minus negative 2 is 10. The negatives cancel. That's evil. We all trip up on negatives at some point. So if I can make all the negatives go away, awesome. And I can, because I know what the hell a negative power means. It just means move me. Move it, and it's not negative anymore. I'm not going to make a negative mistake now. Right? So that's my major suggestion. If you want to do it where you subtract, and you're not having any trouble with it, continue doing that. It's totally legal. That is a property of powers. You can do that. Yeah, exactly. This is not x to the 6. Thank you. You got to be careful. That is a mistake. It should be 8 minus negative 2 is 8 plus 2 is 10. But to me, an easier way is those two x's come up here, and that makes 10. I'd rather flip it up because then it's easier without the negative on it, right? Okay. Very cool.
And you're done with the division. It's no longer a fraction.
That's it. Yeah, exactly. Yeah.
How do you get 5?
Oh, how do you reduce 40 over 32? What goes into both of those? 8.
You don't define
And
it.
8 goes into 45 times. 32, 42. Yeah. When you have numbers, it is just a fraction. 40 over 32, just reduce it.
What if we don't reduce them? Do we get it wrong?
Then you're wrong. In a way, you're wrong. I mean, it's still the same number, but you know you reduce fractions when they're in there. You always do. Give it in lowest terms. All right, cool. Yep.
Can you do an example of that, the longer, of like C?
Oh, okay.
Oh, they have 2 in parentheses? 1C? Or which one? 1C?
Yes, 1C,
yeah.
sorry.
Now on this one, some of you guys did flip it, and that's fine. But to tell you honestly, I would go ahead and multiply these out and see if they're negative and then flip it if it is. Because look what happens here. That's a negative 3, but what happens when you multiply these 8b's by those negative 3b's? What are you left with? B to the what power? 5th power. And then I don't flip it, right? So I'd much rather see what I get after I multiply these out. So what do I get here?
So you're just 6.
I'm not distributing, right? I got to be careful here. I'm not distributing. I'm just multiplying in a smart order. I can multiply. If I have 2 times 4 times 7 times 5, I'm going to do 2 times 5 first because that's 10. And then 10 times 4 and 10 times, I can multiply whatever order I want to. I'm not distributing anything. I'm just moving the 5 over there. Commutivity. Oh shit, there was a reason for that. So here, I can't multiply 2 times a. It's 2a. I can't do shit with that. But I can multiply negative 2 times negative 3. So I'll do it. Right? So I'm not distributing. I'm just multiplying what I'm able to multiply there, right? I mean, here's a simpler example. What's 2x times 3x?
6x.
You didn't distribute, did you? You just put the 2 and the 3 together because you can. You put the x and the x together because you can, right?
Yes.
It's kind of silly to write this as an answer and say, well, there you go, Jeff. You never want to have a number in the middle of everything. It's going to at least come out for the for the coefficient, and then the x and x make x squared. So this isn't really done. This will be 6x squared. I'm just doing, now I've got a few more things going on, but I can still do number times number. A negative 5, A4 would be a to the what power?
-1.
Beautiful. Negative 5 plus 4 is negative 1. And like we said earlier, 8 minus 3 is 5. What's the only thing that wants to flip here?
A.
The A, not the 6. The 6 doesn't get dragged down by him, right?
Right.
The A's not going, I'm going to take you with me. No. 6 is to a first power. He's happy up there. Not everybody's happy. You could do the whole problem by first flipping everything that's a negative power. It would work fine. It's just, in this case, it's easier to see maybe they're going to end up positive at the end anyway. There's no reason to flip them.
So even if that negative 3 was like on the other side of the B, you'd use the standard? Is that right?
It wouldn't really be over here because the coefficient's always going to be out front. It would be a little evil for them to put it because then as a student I'd go, what the hell does that mean? It's supposed to be out front, right?
Yeah.
Okay. So if you guys had a problem like this and over here you'd have the 6 go down, there's no reason for that 6 to go down there. He's to this understood 1 up there. There's no reason for him to flip. And I saw a few too many of this, like I saw this, something like that, right? And what was the mistake somebody made here?
The negative coefficient, I guess I assume it should.
Yeah, a negative number has never meant flip. It cannot suddenly now mean flip. What is it that means flip? Negative power. Just because it's negative doesn't make it flip, right? It's something raised to a negative power. That's what means flip. So this is where I try to tell you guys, if you ever think math has changed, you're like, why did they change everything? Come see me, because we can't change anything. I can teach you more shit. I can teach you about exponents, but they can't go backwards in time and say, well, now negative 6 means 1 over 6. I can't. That's not true. Negative 6 is not equal to 1/6. That makes no sense. I can understand, though, when you get a little overwhelmed, you're like, negative something meant flip. I better just flip every damn thing as negative, just to be on the safe side, right? I can understand that. Yeah.
When you said don't distribute, do you ever distribute?
How do you mean? No, you definitely distribute. When do you distribute, though? You distribute in 2 different cases. You distribute here, right? That's definitely distribution.
Right.
Why? Because I have 2 terms to take the 2x to. Here, how many terms are there here and here? 1. There's 1 term here, 1 term there, no distribution. Right? If you say distribution too often, you sound like you're drunk. So there's distribution here, and there's also crap. Now I'm not going to be able to say the rest of it. There's also distribution here, right? Because what's got to be raised to the 5th power? Each thing. I like it. So notice how coefficients work well with minuses and pluses. Exponents work well with multiplications, right? Because that's what it's based on. So this would be, what would this be? What's 2 to the 5th power?
45.
What was the second thing you said?
45. 40.
Before that, I thought you said 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Just multiply 2 5 times. A to the what? 10th, not 7, be careful. When you raise the power to a power, you got to multiply, right? A 10, B 15. what I always remember is this means I have 5 groups of 2, which makes 32. 5 groups of 2A's is 2A's, 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 2A's. That's 10A's, right? So that means I multiply. When I raise something, I multiply. When I multiply 2 things, I add their powers, right? Okay, maybe. So if I had A squared A5, that would be A7. And this one here, of course, we should know what that is.
2x squared minus 14x.
All right, I like it. Cool. What's that? I'm sorry?
Could you do an example of number 2, the state whether the following are polynomials and what's epsilon?
What makes something not a polynomial? Either it has a negative power, just something's not a whole number power, right? And what are whole numbers? They start at the number that looks like a whole, 0, and go up from there, right? So whole numbers are 0, 1, 2, 3. So things that aren't polynomials have negative powers, or they have fractional powers, which you don't even know what the hell it means yet, but it wouldn't make it a polynomial, right? So look at your problem again, number 2. Which one of those has a negative power? That's going to be the one that's not a polynomial.
B.
Yeah, it depends on which version of the test you had. The one that's just a number by itself is a polynomial, right? So if I have the number 4, let me do this. What type of polynomial is that?
First degree.
Binomial, right? First degree, I love it. So let's put that in. First degree binomial. It would be really evil of me if I took him away and all of a sudden he's not legitimate anymore, right? Hey, where's your friend the X? He's gone? Yeah, screw you. No, that's evil. I'm saying right here there's 2 terms. They both must be legitimate. So 4 by itself, that's a monomial. And what degree is he? How many variables do you see? 0 degree. So he's a 0 degree. Monomial. There's a gimme for you. Anytime I have a number by itself, it must be 0 degree because you have 0 variables. And it must be monomial because there's 1 term there. Okay. Maybe not. Are you cool with this?
Yeah.
Like, watch this. X squared plus x. That is a binomial, right? In fact, it's a second degree binomial. So both pieces of it must by itself be a monomial, right? That's a monomial, and 2 of them make a binomial. So if you're telling me that this is legitimate, this is a first degree binomial, each piece of them must be a monomial. That's a first degree monomial. That must be a 0 degree monomial because he's a part of a legitimate dude. The only way to make it bad is to have, so not polynomial would be like x plus x to the negative 4. It's got a negative power, right? Or more specifically, if I had 1 over x minus 2, that's not a polynomial because that's x to the negative 1. And again, the whole reason that math people came up with the word polynomial is if I tell you I'm working with a polynomial, that means you can plug whatever you want to into it. Is there any x I'm not allowed to use here? No, I can add 4 to any damn number. Is there any x I'm not allowed to use here? Anything I can't divide by? 0. I can't use 0 here. That's not a polynomial. A polynomial is one that can take any value into it. So that's one reason why a negative power, that's going to be 1 over x to the 4th, I can't plug a 0 in.
So any negative is not.
Any negative power is not a polynomial. Or any, you're not going to see this yet, but any fractional power, also not a polynomial. That's coming up later, so don't worry about it yet. You might not know what the hell a fractional power is. I can just put a fraction up there and there it is. Don't know what it is yet, but I know it's not a polynomial. Okay.
And no degrees then?
If it's not a polynomial, the idea of degree is out the door.
So first degree is when it involves a variable, but if it's a whole number.
First degree is because it's to a power of 1. Right?
Isn't the 4 to the 1?
4 is also to the first power. I love it, but it's not a variable.
So it has to be a variable.
Yeah. What degree is this here?
Third.
Third degree, because the highest degree I see is 3. This degree is
1.
0.
Wait.
2.
Huh?
How many variables do you see?
2.
2. There it is, second degree. How many variables do you see here? 3 x's, so it's a third degree term there. degree for the whole polynomial is the highest degree that I see.
So if that was a 4x squared y, then that'd be the same as like.
So if it was a 4, so if I x cubed plus 4x squared y, what's the degree of this one?
Yeah, so that would be 3?
3.
Okay.
2 x's and a y make a third degree. So degree is very simple. Just count your freaking variables. So why is this guy a 0 degree then? There's no freaking variables. 0 variables, 0 degree.
So we don't have to solve anything.
Now, if I just ask you for the type of polynomial and degree, you just tell me those things.
So that's a
None of them had like terms anyway.
Yeah.
third degree binomial?
Yeah, in this case, third degree binomial. And this is actually also a third degree binomial because the highest degree I see is still third degree.
Mm-hmm.
Okay.
So if there's a negative exponent anywhere in the problem, it's not a polynomial, or
If there's a negative exponent on a variable, if I wanted to be truly evil, I could give you this here. X to the third plus 4 negative 1x minus 7. That is a trinomial. That is a third degree trinomial because 4 to the negative 1 is just the number 1/4.
you're just taking out the 4 negative.
Right? Is there any variable raised to a negative power?
Nope.
No. So it's a polynomial. I just wrote it in an evil way. There. Same thing, right? 4 to the negative 1 is 1/4. So it's fine. All the variables are to whole number powers. So that is a trinomial. It's the variables themselves can't be raised to a negative power. Right? Here I can still plug anything I want to in for x, right? I can plug any number I want to in for x. The 4 is on the bottom, who cares? It's 1/4 of something, I can do anything with it. I can plug anything I want to in there. Okay. Yes? Yes.
So those are trinomials.
Oh, where are you? All right. Whew. It's a major review right there.
Still working.
Okay.
Well, you can erase that.
So any questions from the homework? We last time we made it up to, wow, you guys look really
Did you say that?
very excited about it.
Trinomials down here?
What's that? This will be a trinomial, yeah.
Third degree.
Yeah, third degree. That's the highest degree I see. 1, 2, 3 terms of trinomial. Good. If that's the only thing you have trouble with is telling what kind of polynomial it is and what degree, I'm happy. I don't care nearly as much about definitions as I do about process. It's important to know the definitions, sure, but if you can't factor, you're screwed. If you forget the name of something, who cares? You can look that up.
Right.
Process is much more important at this level. You've got to get the procedure down. If this is the only thing you're having trouble with in that whole chapter, I'm so happy. I'm ecstatic. I love it. Take a good guess on it and keep going. I don't want to say you shouldn't study it, but still. So last time we made it up through 6.3. Believe it or not.
6.3. 6.2.
Well, 6.2, yeah. 6.3 we almost got into, that's right.
Yeah.
Anybody not get a copy of that factoring handout I gave out?
Oh, wait. Yeah, I don't think I did.
You don't have it?
I don't think so. Nope. I don't have it.
You went back there.
She didn't get it.
What's up?
Yeah, I got it. No, I have something. You weren't here. Unless you got a friend in class. Like everything else. Like,
You got that? You got that, yeah.
Master product method. I don't even know.
Anybody else? Oh, sure.
I'm tired of sitting here going,
That's why I have so many of them left.
what's going on here?
he wasn't doing any close.
Yeah, I was here. You just didn't see me.
Don't worry about that.
Right?
Okay.
Don't trip. I was here.
I was spying on you.
You know?
All right, guys. So I'm going to do a really quick review of factoring.
So this is not 60.
Something I want you to realize, I've actually cut out a lot of Math 90 material from the end because you're going to get it in the next section anyway. It's much more important right now for you to get down Solomon equations, like terms, factoring. If you can't get those down, you can't build on top of it to do the other more complicated stuff. So factoring, what is it you always try first? I like it. Let's do this here. So with what I just said, and what somebody else just said, what would you do here? Oh, yeah, GCF would be 4, right? Because some of you guys, what I just said, section 6.3 is all about what if the first number is not a 1? Because remember, if that first number is a 1, it's easy. It's just x and x, and then you got to fill in the numbers that multiply correctly and add correctly, right? That's a 4. That's evil, Jeff, but you can take a 4 out. If you take a 4 out, what's left?
X squared minus 2x plus 2. Oh, 1, yeah, sorry.
I know that's what you meant. Now what can you try to do here? Don't stop. This is a trinomial. This is 3 terms. I should try the whole thing we talked about last time.
Where did 1 come from?
4 comes out of there, makes 1. 4 comes out of there, makes -2. 4 divided by 4 is 1. Oh, actually, let me talk about that real quick. Did anybody think that shouldn't be there at all?
Yeah.
All right, then how do you get that? 4 times there is there. 4 times there is there. Where's this guy coming from? So in one respect, he's a placeholder. That 1 better be there so you get the 4, right? Even better than that is, what's 4 divided by 4? 1. You can never be left with 0 when you're taking something out, because you're dividing it out. When you divide something by itself, it's 1. I like it. So I didn't even realize generally that's a good place for mistakes. Is you think, I've had 4, I took 4, there's nothing left.
Right.
When you take something out, you divide it out. So that'll be 1.
What if it was 15?
Then you couldn't take a 4 out.
So then you can't factor.
Then it would be the next section that we haven't gotten into.
We haven't gotten to yet. All right.
Exactly. Cool.
We'll get there.
We'll get there very soon. So what can I do here?
Break it apart.
What can go here and here? Definitely. X and X. So the whole question, and I desperately, I'm sure you guys you see me trying to do this, but I really want this to make sense. This has got to be X and X. Now I need 2 numbers that multiply by this. Why? Because that's where that number would have come from. It would have come from this times this. And the middle would have come from this plus this, right?
Yes.
So what 2 numbers multiply by 1? Well, there's only 1 and 1.
Negative.
And to make it add to be -2, they both have to be.
Negative.
Yeah, there you go.
Oh, they had to be complicated.
That's just starting us
Let's
off.
start with the easy. Yeah.
Right? That's just starting us off. We
Example
want to make sure
1.
that everybody's on the same track with what to look for. Then we'll make it harder. Step 1, though, is do you understand the process you have to go through? How do I make it harder? I put uglier numbers there and there, but it's the same stupid process, right? It's the same process. That's why I keep saying process is important. If your problem is you make a mistake and you say 2 times 3 is 5 somewhere, that doesn't bother me as much as I had no freaking clue what to do here. That's where I'm more worried. So let's make one a little more difficult. Let's see. Can't remember if I did this one already. I think I might have.
Master product.
Okay, some of you guys call it master product. I love it. Don't really call it that, but
Well, it'd be easier to do it like that, so you don't gotta.
it's still. So master product involves putting that down. All right, you guys done it that way? Okay, because this is actually the same thing I do. I just don't make a big X. But if it helps you organize your thoughts, I like it.
Okay.
Otherwise, I don't really see a need for it. Tell you honestly.
Well,
But what am I trying? What's the process here? What can I definitely put down here and here? X and X. So that's the part that there's no question. So if you have no idea, at least put those down. You'll get something. I'll at least know that you know kind of where you want to go. These 2 are the ones that are freaky to me. 10 times 1 is not 60. How do you mean? I'm sorry. Well, these last two things are going to be just numbers, right?
Equal negative 60.
Okay, side note. Okay. So remember how we, now let me just do this for a couple of you guys who weren't here. If you ever miss a day, you definitely have to come see me in my office because you've missed some key stuff here recently. But if I have just, the way we kind of built up to doing these was we took a few of these and multiplied them out to see what the hell keeps happening. If I can see the pattern, I can work it backwards, right?
Right.
So,
Reverse engineer.
x squared,
6x.
6x.
4x.
24.
So I get x squared plus
10x.
10x plus 24. Where did that 10 come from? 4 plus 6. Because that's going to be in the middle, aren't they? So the 10 came from these two numbers adding, and the 24 came from these two numbers multiplying. Why is there no x with them? Because neither one of them has an x. Why is there an x with the middle dude? Because it picks it up when you do the multiplication, right? But the important thing is, the number that's in the middle is the sum of these two numbers, correct? The numbers at the end is the product of those two numbers. So I can make it a very different kind of problem. I could do this. What two numbers multiply to be negative 48 and add to 2? That sounds more like a... Yeah. But how do you start? How do you attack this kind of problem? Well, you start breaking negative 48 down, right? That's one way to do this. What multiplied being negative 48? 12 and 4, right? But no matter which way you put the negative, it's not going to make 2, is it?
No.
What's another way to get 48? Well, 8 and 6. And to make 2, which one's going to be negative?
6.
The 6. So that's the kind of playing with numbers you have to be able to do, and all of you should be able to do this. The way I like it is I keep in mind, what does this really tell me? They're going to be different signs, aren't they? Because to multiply negative, they have to be different signs, which means they're going to subtract to 2. If I add two numbers that have a different sign, I'm going to subtract them, right?
Mm-hmm.
So they have to be 2 apart. So another way to do this problem is say, okay, 7 and 9 are 2 apart. There you go, see, that makes 2. But what's it multiply to be? 63, so that's no good. It's supposed to be this. That's too big. Let me go down a step. Negative 6 and 8. Oh, that makes 48. Sweet. That's another way to do the problem. So when you have a problem like this, it's 3 terms, and the first number's a 1. These are set, x and x. That's you only make x squared. The whole issue then is, what are the numbers that go here to make the whole thing work? And what 2 things do those 2 numbers have to do? Multiply to be 60, negative 60.
So it'd be 15 plus. 15 plus.
Exactly, and add to be negative 11. And if you keep going here, you'll eventually get 15 and 4.
So
15 times 4 is 60, right?
Yeah.
And which one's got to be negative, so it comes out to negative 11? The bigger one's got to be negative. Right? The bigger one has got to have that sign, right?
Right.
Because whatever the bigger one is, it's going to be the end result.
It doesn't matter which side you put them on.
Doesn't matter, because again, I'm multiplying. Doesn't matter what order. Yeah. So then I could put minus 15 plus 4, or plus 4 minus 15. Either way, comes out the same way. And let's watch. Watch this. What do you get when you multiply this out? X squared
Negative 15.
minus 15x
Plus 4x.
plus 4x
Minus 60.
minus 60. What's negative 15 plus 4?
Negative 11x.
Sweet. Right? That's how I check.
Boom.
How do I check I did it right? Well, I multiply the damn things back together. That's what I'm claiming. I claim that this is the same as this. How do I check it? Do it. Do it.
That's a proof, right?
Hmm?
Is that a proof?
I've proven that this is this, because I did it. Yeah. Cool. All right, so I really, sometimes you guys take each problem as if it's something different you have to memorize. Any 3-term problem like that, that's got a 1 in the front, it's the same process. I attack it the exact same way. The numbers are different, but I don't care about that. I can handle that. I just want to know the process. So what if I had, let me see if I could be more evil.
Yeah.
Wow.
Really?
Yes.
Really?
They're evil.
Yes.
I don't like it.
You ready?
No.
We're gonna do this together.
Okay. Let's do it.
Is that better? Make you feel better?
It works.
You're not going to see one that ugly in the homework, but I want to show you that the process. Now, why would I not want to start here and start factoring this? Because how many factors of this are there?
A lot.
A lot. So screw that. A lot of times when you've been taught factoring, they focus way too much on getting the numbers that multiply correctly first, and then check to see if they add. Screw that. I'm going to get the numbers that add correctly first, and then check to see if they multiply correctly, right? So what's got to be true about my two numbers? They got to be opposite sides. So they have to be 3 apart, don't they? So let me start us off with a stupid suggestion. 10 and negative 7. Don't they make 3?
Yes.
Yeah.
But do they multiply to be that?
No.
They multiply to be what?
Negative 70.
So that's obviously wrong. Now can you give me a better suggestion? How can I improve my attempt here?
It's got to be bigger.
It's got to be bigger.
It's got to be bigger.
So let's step up a few here. Let's go 15 and what? To make 3. Negative 12. Doesn't that make 3?
That makes 3.
What's 15 times 12?
180.
180. I'm getting closer, aren't I? I'm still kind of far away, but do you guys see how now it's like a Price is Right game? Just if I'm too low, just too low, higher, too low, higher. You know, just keep on making them higher. So let's go up to 20,
Negative 17.
negative 17. What's that? 340, right?
Getting close.
A lot closer, right? I'm almost there.
23.
23 and 20. And that, of course, is 460. Do you guys see what I mean?
Yeah.
Now, unfortunately, if you're not as comfortable with playing with numbers, this is going to be difficult. If you're more comfortable with numbers, it's going to be easy. Because it's really all about playing with the numbers until you get them to work correctly, right?
So the only time you put a number outside the parentheses, you pull that number out of
Exactly.
box.
And of course, this I can't pull anything out because he's only got 1. What did we just find, though? What's the answer then? From what we just
X
found.
plus 23 times X minus 2.
Yeah, this is x and x to make x squared, right? Always.
Yeah.
If there's a 1 out front.
Plus 23
I like it. Plus 23
minus
minus 20. Sweet.
What if it was cute?
That's the next section. After the next section.
The next chapter. Come on.
I like it. All right, here's one like what you're saying, Nicole. You ready? Everybody else is looking like. Let's see.
Yeah, right?
Oh.
Yeah.
So you can take 5.
Yeah, I think you know.
Take X out.
Now you got 3 per inch.
Well, actually, you take 5X.
Notice, get the whole thing down, right?
5X.
You think it's
Factor, right?
Yeah, what can come out?
5x.
And an x.
5 and an x.
Cool.
Yeah, X squared.
So what's left here? The 5's gone. I had 3, took 1, I got 2 left.
Yep.
20 divided by 5,
4X
4, and I had 2x, took 1, I got 1 left.
3.
plus 3.
15 divided by 5 is 3, and I took his only x away. Aw. Don't stop there, though. A lot of us, of course, are kind of new to the fact that we feel like we've done enough. But we haven't. This is 3 terms. Maybe I can go further, right? Don't forget this dude. He comes for the ride. What do I put in the first place?
X.
And what 2 numbers multiply by 3 add to be 4?
3 and 1.
It's got to be 3 and 1. That's the only 2 numbers that multiply by 3, right? Whole numbers anyway. So plus 3, plus 1, or the other way around. I'm done. If I write this down, I'm not right. Because that does not multiply to be this, does it?
No.
Don't forget the part that you took out. He's got to come for the ride. He's done. He just comes for the ride.
How come you couldn't take anything bigger out than 5x?
Because he only has 1x.
I see. Yeah.
And they only have a 5 in common.
That's true.
Cool. That's why.
I forgot about that.
I'm with you. All right. Let's see. Let me let you guys try a couple more of these out. These I'm just going to stand here and stare at you while I do.
All right. Thank you, T.
Yeah. Slacker. Two of my classes. So. Just wave in the back. It would just say factor. This is a good question. Somebody had, what would be in the instructions here? They'd have to say factor. If they said simplify, you'd say I can't. There's no like terms, I can't simplify it. Simplify means do the operations. Factor means undo the operations. Tear it back apart is what factor means. They're actually opposite instructions. So this would have to say factor. So what do you guys get for this one here?
X minus 6 and X minus 7.
I like it, because they have to add a 13. Negative, they both have to be negative, so it comes out positive. And 42, there's not many ways to break it up, so it shouldn't have taken forever. So 6 and 7, they both have to be minus to make negative 13. Alright, so I did kind of the reverse on this one.
X minus 4, X plus 10.
I like it.
Positive 10.
So 40, there's only a few ways to factor that, dude, right?
Yeah.
So again, if you the work you could do would be like this, 8 and 5, but that can't make 6. That can make 3, right? 3 or negative 3. So that's no good. 2 and 20, that can never make 6, right? That can make 18 or negative 18. So we're kind of running out of options here. 10 and 4, and that can make positive 6 as long as the little dude's negative, right? So it has some positive left over. So plus 10, minus 4. You can always check yourself by multiplying it back out.
Yeah.
If it were negative 10 and positive 4, the middle would have to be minus 6. Yeah. All right, all right. Now, I'm going to try to take some baby steps into the next section. And this process I'm going to show you now, some of you guys might could use it on this one, but it's extra work. This is a one-step problem. Whenever you see a 1 here, that is a one-step problem. That one step sometimes is rough, because the numbers might be ugly, but it should just be a one-step problem. Why is it harder then? Why is something like this? Let's do what I know. There you go. Yeah, here, what's got to be in the front? X and X. No question, right? So it doesn't matter where I put the 7 and the 6? No, because either way I'm going to put them, I'm going to multiply it by X. 4x squared could be 2x and 2x. Right? Which means when I go to FOIL it, wouldn't it double whatever number's there and double whatever number's there?
Yeah, or
shit.
4x and x.
Now, I'm not trying to make it seem like it's impossible, but I want you to understand why I've got to do it a different way. There's a different process here. It's not evil. It's just longer than this one. Why? Because there's extra crap out here that I can't take out. I can't take a 4 out, can I? Shit. So somehow I've got to take it into account. Or, what else could it be? 2 and 2 makes 4, or
4 and 1.
exactly. So there's a lot of different options here. Now, some of you guys, if you're able to play with numbers pretty well, then you could do a method called trial and error, which is where you just put down everything it could possibly be until you get it right. And the better you are at playing numbers, the more you can just automatically rule out. You're like, can't be that, can't be that. Let me try this, I'm done. If you're not good at playing around with numbers, you're going to want to do it the way I'm about to show you. Right? Can you guys tell me? Yeah, exactly.
Okay.
One of the most easiest factoring methods really is grouping. When there are 4 terms, I just group them and GCF it, right? It's not that bad. So if I could just make this, why would this not be a grouping problem? There's only 3 terms. Grouping needs at least 4. So somehow this method is going to take these 3 terms and make it 4. And the way we're going to do it is we're going to take this middle term and write it as 2. For example, -5 could be -2x minus 3x, right?
Yep.
Then it would be 4 terms. Right? I'd be surprised if that's the way it works. It's not the way it works. There's only one way to split up the middle term, and there's how many things could it be? An infinite number. It could be 7 and -7 and 2, right?
Mm-hmm.
Wouldn't that make -5?
Sure.
All right. So the nice thing is, you don't have to try every way until it works, because that would be just as crazy as the first method I said. There's a very specific way to do this. But let me take a second side note. A little motivation as to how this is going to work. So it's just like we did earlier when I first taught you how to do this kind of problem. Let's write a couple of things that would actually end up with a number out front. So to make a number happen out front, wouldn't I need like a maybe 3x there? And maybe a 4x there? How we doing? So what I'm trying to do is just like I did earlier over here. How did we figure out that I need 2 numbers that multiply to this and add to be this? How did we figure that out? We took some multiplications to see what would happen, right? We multiplied and we noticed that the middle term is going to be -7 plus 6. So the middle term's got to be the sum of those, and the last term is going to be those 2 multiplied, right? So we looked at some examples going forward to help me figure out how the hell to go backward. So I'm going to do the same damn thing. How do I make a problem so it doesn't just have a 1 out front? Well, I don't just have 1s out front, do I? I have something else, like 3 and 4, for example. This is a side note example. It doesn't have, it's not the answer to this. It's just my trying to see what's going to happen. Right? I really want you guys to see what I'm doing. Yeah, exactly. Because just like we did over here, I just made up stuff. I just made x plus 3, x plus 5, and then we just did it, and we saw what happened. And they helped us figure out, oh yeah, the middle terms are going to be 3x and 5x, 8x. And the last term is going to be 3 times 5, 15. So I know that I need 2 numbers that multiply by this and add to be this. That's what we did that for. Let's do one just like that for this. What do we get here?
12x.
Plus 10. What do you get in the middle now?
-23x.
I like it. So notice something. Is the last term still these 2 multiplied?
Yes.
Yes. Is the middle term still these 2 added?
Yes.
Really?
No.
What's -2 plus -5?
-7.
Not -23, right? Now, why didn't it work here as it did before? Because these stupid numbers screw me up, don't they? Here, what do I have here? I got a 1 and a 1. So isn't it still 3? 3 times 1 is still 3. 1 times 5 is still 5. They make 8. They make 8. Oh, that stupid 3 came in and made it a freaking 15 now. And that 2 came and made me, stupid thing. Right? You guys kind of with me here? Now, I'm trying to show you why we have to attack it differently. Don't freak out and go, holy crap, how the hell am I going to do this? It's not going to be that terrible. Believe me or not. Sure, it doesn't really change much. Not the bottoms up method. You can definitely not do that. Bottoms up is where you do some weirdness and then you divide by something and then the answers come out of nowhere. I don't like that. Right? Obviously.
I got the same answer.
What do you mean? Where? I haven't gotten any answer yet.
Oh, for the 4x squared minus 5.
Okay.
I did the x and I put negative 24 on the top and negative 5 on
Okay, cool.
the top. That's fine.
Yes. Cool. But where did negative 24 come from? That's the part I haven't taught yet. That's the part you remember from before.
Yeah.
But I haven't talked about it yet.
Okay.
So that's perfect. You can do that one. So what has to happen then? Pretty obviously what has to happen is these are a mixture of the first and last terms, right? You with me on that? Because the 15 came from the first guy times the last guy there. So in order to start a problem off like this, I can't find factors of this to add to be this because we know it won't work. It doesn't add correctly here. I've got to take this 4 into account. So the first step on this kind of problem is to multiply the 4 by the negative 6. Now if you like drawing an X there, feel free. I really don't understand how that helps you organize your thoughts. But if it does, I love it. Do it. Sort of like lucky socks. If you're wearing them yesterday, you need to get some different socks. So now, here's the cool thing. When there's a number out front that's not 1, you have to take it into account and multiply. So you don't find factors of this that add to be this. You find factors of this that add to be this. And what factors of negative 24 add to be negative 5?
8 and 3.
8 and 3, right? 8 and 3 multiplied to be 24. They'll add to be negative 5 if, which one's negative?
No,
Careful.
8.
The bigger dude's got to be negative. All right. All right. At least everybody's face before I could tell that. I could tell you guys are like, God help me. Yeah.
And this is if you can't take something out of all three, right?
Exactly. If I could take a 4 out, ain't no way I'm doing this crap, right? I'm going to take that 4 out because then I make a 1 there. I'm SOL here, right? Because I can't take a 4 out. I've got to have a different way to attack it then. And again, if you like trial and error, keep doing it that way. It's fine. It just means you can play with the numbers pretty well, so you can do it that way. I like this way. This is what I call the, I don't call it this way. It's actually the way I was taught a long time ago, surefire method. Probably because it comes from Georgia. Surefire method. But it's called the surefire method because surefire it'll work for you. No matter if it's factorable, this will work. Period. So here's the trick. Not a trick really. Here's the next step. I can't go straight to the answer because again, is it 2 and 2? Is it 1 and 4? I don't know. Shit. What I do is, like I said earlier, I make this middle term into 2 terms, so I get 4 terms all together. And what do I do when I have 4 terms? Group. And grouping is relatively easy. So what is negative 5x? Negative 8x plus 3x. Did I really change anything? No, I didn't change a damn thing because that's the same as this. But now what can I do with this? Group it. I can group it now, right? So this step here, this step right there, when you multiply these and get the numbers that work, gives you the only 2 numbers that will make the grouping work. That's why that step is important. Right? If you just pick 2 numbers out of nowhere, it will most likely not work. That sucks. Yes?
So you put the 8 and 3 instead of 5?
Yes. And again, on one level, it's kind of like, wow, Jeff, good job. You know, really nice. 8 and 3, that's make 5 and 6. But what I've done now is I made 4 terms. Group. What comes out of these 2?
4x.
4x, and what's left?
X minus 2.
2, exactly, right? So far, so good?
Yep.
Grouping is relatively easy because it's normally pretty easy GCF problems, right? What comes out of there?
3.
Positive 3. Am I allowed to go to the next step?
You are now.
Because these 2 are the same?
Yep.
So what do you get? X minus 2?
4x minus or plus 3.
4x plus 3. Cool. It's yeah. The whole day today is going to be factor. Is the instructions.
Just when you see like these, if we have numbers at the beginning, you'll know.
If you see a number out front that's not 1, and in fact, the funny thing is, even here I did it. What's 1 times 42? 42. See? So we've been doing it the whole time. It just didn't change anything until the first number is not 1.
So we can do that.
real quick, I told you earlier, it'll actually work here. Let's do it here real quick, watch. You don't have to, but let's see if it works. 42 is -6 and -7, right?
Yes.
So I could take this problem. I can write -13x as
Negative.
-6x, -7x. What comes out of these two?
X.
What are you left with?
X minus 6.
And what comes out of those two?
7.
What kind of 7? -7. So that changes sign to plus x, and that changes sign to -6, right?
Yes.
And then x minus 6 comes out. X minus 7 in there, same.
Yeah, that one's X. Oh, no.
Do you see that? Yeah, it's like 2 extra steps.
Mm-hmm.
I see people doing this way for everything, and the reason I'm not really that concerned about it is because at least you're getting more grouping practice, right? But you should be able to do this kind of problem in one step for most of them. Because the funny thing is, if you can get these two, you're done. Those two numbers, you're done. Over here, those two numbers, I'm not done. Shit, I got to do this. So it's kind of funny over there. If you're able to get those two numbers, there's no reason to do all these steps. You just put them in, you're done. The reason I think people do this is because they forget when they're done. Which problem is it? Oh, screw it, I'll just do everything like this. But when there's a 1 out front, my whole thing is just what two numbers go there. That's it. When there's a number that's not 1 out front,
That you can't take.
I don't know how it's gonna. I don't know what that's gonna break down to be. I need some other process to help me, right? Okay.
And what if it's a number that you can take out, though? You just
Oh hell yeah! You definitely take it out if it's a number you can take out. All right, here. Let me give you guys one to try on your own.
No. Are we into 6-3 lecture now?
Oh yeah.
This is 6-3.
I don't know what number I'm on. Just an example. Really quick, just before you guys get in. How would I check this to make sure I'm right? Foil it out, right? See, if you have time on a test, you get done, you just go back and foil out what you've done. Make sure it actually comes out to be this. Don't make a mistake on your foiling, though. That'll suck. But foiling should be easier than factoring. Good.
Yeah, it won't be -60.
Just to make sure everybody's on the right first step. First step is that. Find factors of that make 11. And some of you guys might remember we did that earlier today.
Oh, maybe 15.
Yeah. Remember that? We did that earlier. And if you're not sure, you just start taking 60 divided by 2, divided by 3, divided by 4. That's your last resort, really, but you can just do that. Alright, we'll see. So what's your next step after that? What's your next step?
Split open 6x.
Yeah, take this, split it up. So D's still there. All I'm doing is rewriting -11 as -15x plus 4x, because that's what -11 is. Now, real quick word. If you reverse these, it'll still work. And we saw that on grouping, remember?
Yeah.
If you reverse these, it'll actually still work. I just always put my minus first if I have an option so that I don't have that negative mistake that happens when there's a minus in the middle here, right?
Right.
I like a minus here better than there, because the plus there is easier, and I have a choice. So what comes out of these two?
3x.
Good, 3x.
Yes.
2x minus 5.
I love it. Plus 2.
2x minus 4.
So you know you're on the right track because those